Hey guys, welcome to our channel. So we've been decoding REM Losing My Religion. We're going to try to get right into this. Um, Set enough, change to set it up, and in order to get to extract what actually changed, you have to first find out what didn't change and eliminate it. So since this S in set enough is over here and set it up, we'll eliminate this S. Since this I from set enough is still over here and set it up, we'll eliminate the I. It didn't really change. And this E from set enough is still over here and set it up. So we're going to eliminate this E. And this U in set enough is still over here and set it up. So we're going to eliminate this U. And that's everything that was the same. That's everything that didn't change. So to extract what changed, you take A, D, N, O, G, H, T, T, P, what you're left with, and that happened twice. So you bring A, D, N, O, G, H, T, T, P down twice. Then we use this numerology chart to convert that into numbers. And what you get is 1, 4, 5, 6, 7, 8, 2, 2, 7. And that happens twice. So once you get to this overlap, going forwards and backwards, then you're done. I mean, when you get to it going forward, you can start coming back. You get to it coming back, you're done. All right. So now we've already got the letters to go through all the categories. We got some translations out of it, found some interesting stuff. We got the numbers to go through the stock market, finance, genetics, medical, chemical, and now we're on atomic numbers. So if you start with atomic number 14, you got silicon on the periodic table. Atomic number 14, silicon. And it's an element with, when ultra pure, is a solid with a blue-gray metallic sheen. One of the most useful elements to mankind. It's used in alloys, including aluminum, aluminium, as it's spelled here, or aluminium silicon, ferrosilicon, iron silicon. And these things that it's used to make, dynamo and transformer plates, engine blocks, and cylinder heads. If you remember in technology, we came across a company that made this very stuff. So that's kind of interesting. There's more uses here, but we're going to go to biological role to try to get through this. It's essential to plant life, but its use in animal cells is uncertain. So, but if you move on from that, you have atomic number 45, which ends up being rhodium. And rhodium, atomic number 45. And rhodium, its symbol is RH. These are the symbols for it on the periodic table. It's a hard, shiny, silvery metal. The major use of rhodium is catalytic converters for cars. It's also used as a catalyst in the chemical industry for making nitric acid, acetic acid, and hydrogenization reactions. And there's no known biological role, and it's a suspected carcinogen. So if you move on from that, you have atomic number 56, which ends up being barium. And barium, atomic number 56. Barium is a soft silvery metal that rapidly tarnishes in air and reacts with water. It's not an extensively used element. Mostly in drilling fluids is used, and gas wells, for oil and gas wells. It's used in paint and in glass making. Barium components are toxic. However, barium sulfate is insoluble and so can be safely swallowed. According to the Royal Chemistry Society, I don't know that I'd swallow it. But it has no known biological role, although barium sulfate has been found in one particular type of algae. So, but if you move on from that, you end up with atomic number 67, and that ends up being holmium. So this is number 67 and holmium. These are all on the periodic table, by the way, guys. All on the periodic table, and we're on the Royal Society of Chemistry in all these. So, holmium is a bright silvery metal. Holmium can absorb neutrons, so it is used in nuclear reactors to keep chain reactions under control. And it's also sometimes used in magnets. Holmium has no known biological role, and it's non-toxic. But if you move on from that, you have atomic number 78, which ends up being platinum on the periodic table of elements. So there's 78, there's platinum. A shiny, silvery white metal as resistant to corrosion as gold. It has no known biological role and is non-toxic under biological role here. Where we've been reading those from. Uses. Platinum is used extensively for jewelry. Its main use is in catalytic converters for cars, trucks, and buses. It accounts for about 50% of the demand each year. Platinum is very effective at converting emissions from vehicle engines into less harmful waste products. It's used in the chemical industry as a catalyst for production of nitric acid, silicone, and benzene. And there's more, but it looks like optical fibers and LCDs, turbine blades, spark plugs, pacemakers, and dental fillings. Platinum components are important chemotherapy drugs used to treat cancer. So, not even going to get into that, my opinion on all that. Anyway, biological role, no known biological role, and is non-toxic. All right. If you move on from that, you have atomic number 82, and that ends up being lead. I think we all know what lead is, but there's atomic number 82, and it's lead. Or Pb is its symbol on the periodic table. It's a dull, silvery gray metal. It is soft and easily worked into sheets. It's easily worked in corrosion-resistant metal. Has been used for pipes, pewter, and paint since Roman times. It has also been used in lead glazes for pottery, and in this century, insecticides, hair dyes, and is an anti-knocking additive for petrol. All these uses have now been banned, replaced, or discouraged, as lead is known to be detrimental to health, particularly for children. And there's no known biological role. Looks like it can accumulate in the body and cause severe health problems, according to this. So if you move on from that, you end up with 22, atomic number 22, and that ends up being titanium. Atomic number 22, titanium. It's a hard, shiny, and strong metal. Its uses looks like they're extensive, so we're not going to read them all. It's found in surgical applications, spacecraft, aircraft, missiles. And also sunscreens. No known biological role, non-toxic. And it can withstand high heats. I know it says that somewhere in here. But if we, oh yeah, it says it up here with the spacecraft because of extremes of temperature, actually. It can withstand extremes of temperature. But if you move on from that, you have 71. No, titanium. Lead, titanium, and 71 is lutetium. Atomic number 71. We're still going forward here. And we're in the overlap. And 71 is lutetium. It's a silvery white, hard, dense metal. It's used little outside research, a few commercial uses as a catalyst for cracking hydrocarbons in oil refineries. Lutetium has no known biological role and low toxicity. So, if we move on from that, you have atomic number, and that, by the way, that gets you through. Why is that there? Hafnium. That gets you through going forward. So now we start coming back, and you take your first two numbers coming back, 72, 72, and that ends up being hafnium. 72 and hafnium. Oh, come on. And hafnium is a shiny, silvery metal that resists corrosion and can be drawn into wires. Its uses as a good absorber of neutrons and is used to make control rods such as those found in nuclear submarines. Very high melting point because it's used in plasma welding torches. Because of this, it's used in plasma welding torches. It's been successfully alloyed with several metals and is used in electric insulator and microchips. That's fun. While hafnium catalysts have been used in polymerization reactions. No known biological role and low toxicity, but toxicity nonetheless. So, but if you move on from that, somehow let's do Cobalt was supposed to be coming forward, guys. Somehow it got out of place. It's number 27 on the periodic table. We're supposed to be going forward anyway. Cobalt. And this is 27 going forward. We're actually skipping back because I don't want to redo the video. A lustrous silvery blue metal, and it's magnetic. Cobalt is like iron and can be magnetized to make magnets, alloyed with aluminum, as it's spelled here. So it's got other uses: jet turbines, turbine generators where high temperature strength is important. Cobalt salts have been used for centuries to produce brilliant, bright blue colors in paint, porcelain, glass, pottery, and enamels. So, and there's more there, but and cobalt is an essential trace element and is its biological role and forms part of the active site of vitamin B12. The amount we need is very small. So that should have been coming forward. But we are still coming back. We've got hafnium already. And so now we're going to move on to number 28. Atomic number 28 then is nickel. Atomic number 28, nickel. These are the symbols, but I haven't been going over those. A silvery metal that resists corrosion, even at high temperatures. I think we all know what nickel is, guys. Its biological role is uncertain. You can get nickel poisoning. I know that. I'm sure I know you can. It can't be avoided completely, but if you get too much, I know that even though I'm not so sure that it says it here, yeah, it's anyway. We'll just go with what it says here. Some nickel components can cause cancer if the dust is inhaled. People are allergic to contact with the metal, and it can't be avoided completely. So take a little in our diet, it says. But anyway, if you move on from that, you got atomic number 87. Atomic number 87 is francium. It's number 87 there. It's an intensely radioactive metal, has no uses, having a half-life of only 22 minutes, and no known biological role. And it's toxic due to being radioactive. But if you move on from that, you have atomic number 76, which ends up being osmium. Atomic number 76 there, osmium. Whoop. Osmium, OS. Shiny silvery metal that resists corrosion. It is the densest form, or it's the densest of all elements, and is twice as dense as lead. Has only few uses, alloys and such. Fountain pen tips. Instrument pivots, needles, and electrical contacts. That's good. It is also used in the chemical industry as a catalyst. No known biological role, but not toxic. So if we move on from that, you have atomic number 65, and that is terbium. Terbium. Atomic number 65, terbium. Periodic table, again. A soft silvery metal. It's used to dope calcium fluoride and strontium, molybdate, all used in solid state devices. And so it's got some more uses, but biological role is there's no known biological role, low toxicity. If you move on from that, you have atomic number 54, and that is xenon. 54, xenon. Colorless, odorless gas, very unreactive. It has some uses. Certain specialized light sources. It produces a beautiful blue glow when excited by electrical discharge. So, propulsion systems. Silicone microprocessors. So it's got some uses, but no known biological role. It's not toxic, but its components are highly toxic because they are strong oxidizing agents. And if you move on from that, you have atomic number 41. That ends up being Rhodium, a silvery metal that is very resistant to corrosion due to a layer of oxide in its surface. On its surface, excuse me. Rhodium is used in alloys, including stainless steel. So it's used in alloys and stuff, building and oil rigs, beams, gas pipelines. Has superconductive properties. It is used in superconducting magnets and particle accelerators, MRI scanners. So added to glass. And no known biological role. And finally, if you move on from that, you get atomic number 17. Now we're in the overlap, and that is chlorine on the periodic table. Atomic number 17, 17, chlorine. A yellow-green dense gas with a choking smell. Chlorine kills bacteria. It's a disinfectant. I think we all know what chlorine is. And the chlorine ion is essential to life. But, you know, chlorine, we get most of the chlorine we need from salt. So, and that gets you through going forwards and backwards in atomic numbers. Did we get all that? That was a lot. But we're going to let this video go at that. Next, we will be doing probably artificial intelligence, so I don't space it. And then laboratories, research groups, technology, and random hits still to come on this. Then we'll, if nothing changes our mind, we'll check the gematria on North Dakota University against all the other Mandela effects we've connected so far, and see if it connects or if it doesn't connect. So that's going to be it for this one for now. Thanks for all your thumbs up, thumbs down when appropriate. Thanks for all your comments, leads, feedback, and subscriptions. And thanks for watching, guys. And for now, you guys have a great rest of your day, evening.